I'm not sure if I draw those perfectly. I think that the symbol might have some more like horizontality to it than this, but this will do the job okay. So yeah, this is what you've been waiting for, Zach in particular. It's an uppercase Greek letter sigma, and it is the symbol that we use for summation. It is just a universally accepted notation for the sum of a series. And so the way it's going to look is this. And you better get used to this because it's kind of all you're going to see for the next couple of days of this class. So here's the English, the interpretation of it is not something I bet you wouldn't just figure out on your own. It says start at the fourth term, end at the ninth term, and sum all of the terms in between, including the fourth and the ninth, for that expression. So first off, would you declare that this is arithmetic or geometric? It's definitely arithmetic because it's going up or down by two each time, right? So it's whatever it is, it goes down two, down two, down two. You can tell that from the slope, -2, right? And so there's a little bit of a modified formula that we want to use. And quite frankly, you don't have to use this modification. You can use the same formula that you used before. You're just going to have to get a little bit creative, not even really super creative. Just be aware as we go through this as things change. But anyways, the formula you're going to want to use for this is as follows. So, and I've gone back and forth, not literally talking to myself, but trying to decide whether or not I want to modify this. And I do. Whether we modify it formally or not, I want to at least have this conversation with you. So, um, what you normally think of as a sub one is the first term. And if you were to write out the series of terms that are defined by -2n plus 5, the first one would be not what you think. And so what I did, and I've never really done it, and you can tell me if you think this is stupid, but what I did yesterday and today as I was working through these was I thought about maybe modifying this formula, and instead of writing it like this, I know if I were a student that this would have helped me. So let's write it as n times a sub first, or actually, let's not even do that. Let's go a sub start. That's what I wrote down, plus a sub end, which I know seems really odd, and it's not like you won't ever see that in a math textbook. But I know the struggle I've had in the past when people go to learn this is they think that a sub one quite literally means the first term of the entire sequence, and it doesn't. It equals the first term that we care about, which in this case specifically is the fourth term. So these are the same thing. They say the same thing. Just I didn't know what verbiage you'd want to use to make your lives easier, but I'll assume you just wrote them both down and that I can erase them. Is that about right? And if you hadn't, I'll give you another few seconds here. So you're going to find the arithmetics to be completely pleasant, and even the geometrics just they're not that bad, but just new notation is always a little odd. So those are the formulas that we're going to use um, when we're working in sigma notation. And let's get to it. So if I wanted to find what this says, can you kind of coach me through the English of it? I think I already said it once, but which term am I going to start with? The fourth term, correct. And so my starting term is my fourth term. We're going to call that a sub start. Okay. I'm interested in that term. And then I'm also interested in the the end. And so I'm interested in a sub end. And so when you see the original formula that I wrote, those are what you would see as a sub one and a sub n. But I do think it's going to benefit us just to literally use words. Start, end. Okay. And then the other thing I need for my formula is n. And n is the number of terms. And that's never going to change. So how many terms are going to be in this partial sum? I mean, I know the answer, and it's not four. It's not three. I'm going to tell you what it is, and you're going to see if you can figure it out. Nine is what I would have said, but it's not right. If I were in your seat, I would have said nine because I mean the top number is nine. Said go to nine, right? The answer is six. That is right. And so the old rule, the old Curious George rule, is that if you're going to count numbers, if you're going to count the terms 4 through 9, the old rule of thumb is that you subtract and then you have to add one, and that accounts for your starting position, right? But if you wanted to see it like counting on my fingers, if I count the 4 through 9, I go 4, 5, 6, 7, 8, and boom, there's that mysterious sixth term, right? So the formula you're going to want, good job, Sutter. The formula you're going to want to work with from here on out is to find n, you take the ending term number minus the starting term number, and always remember to add one because you got to account for where you start, right? So that's why in this case n equals 6. There are 6 terms 4 through 9, not 5. Your brain would want to tell you 5, but it's 6. And so what we're going to do now in order to make this function or this formula work for us is we just have to answer all 3 of these questions. And the math is simple. We're not going to need our calculators for this, I don't think. Geometric, we're going to go calculator heavy, but this pretty simple. So the starting term is the 4th term. Got it? And that means we're going to put 4 right into the expression. Mental math. What's -2 times 4? -8 plus 5. So the first term that we're interested in is -3. I want to reiterate, if you wrote out the entire sequence of terms defined by -2n plus 5, -3 is not the first one. It's not technically a sub 1, just for the record, okay? It's the first one in our math problem. That's why there can be some confusion. And then we want to find the ending term, which again is the 9th term. And that just means go to the red arrow and change it into 9. What's -2 times 9? -18 plus 5 is -13. And we now have written down here in red all 3 of the characters to complete this performance of the show. And so using our formula, it simply says to take, and you already wrote it down, it says to take n times the value of the first term plus the value of the last term and to divide it by 2. Okay. I mean, if you could see this series written out, the numbers that you would see would be -3, -5, -7, -9, -11, -13, right? That's what we're really trying to say here. And then you math. And the math, again, I still think we're in mental math zone here. What's -3 plus -13? And then what's 6 times -16? -96. And what's -96 cut in half? Careful. -48. So for our first sigma notation problem, we would say that the answer is -48. Again, what it simply means is if you could get in there and look at the 4 through the 9th terms, I said this once. So this series would have -3 for its 4th term, -5 for its 5th term, -7 for its so on and so forth, -9, -11, -13. So these are the 4th term, 5th term, 6th term, 7th, 8th, 9th. So the proof is pretty simple there that if you just add those up manually, of course, you'd still get -48. Let's go again. Let's do one more. You okay?
Since these are like series in the fact that we're adding them together.
Right. Yes, we are doing summations, just for the record, okay? We're still finding what we call partial sums. So we're not summing an entire infinite series. We're finding partial sums, meaning we're going in and grabbing out part of a series, an infinitely long series. We grab part, lay it down, and then we add them all up. So in this case, we're going to go from, what did I have on this one? 5 to 61. So n equals 5 all the way up to 61. And the expression will be double n plus 3. So 2n plus 3. Arithmetic, because it clearly has a slope of 2, so it goes up 2 for every one we add. So arithmetic all the way, because the formula is going to change, of course, when we get to geometric, right? Yeah, let's do it. So our cast of characters is a sub start. And remember that a sub start is like a sub 5. I'm going to write it this way this time. We clear? I need that term, starting term. What is a sub 5?
13.
Good job. That's just changing n into 5. And then what is a sub 61? 225. And what is n?
57.
57. You guys are quick studies. Good. And that's the cast of characters that you need to fill out in order to find the sum of an arithmetic series if it's given to you partially like this in sigma notation. And we do need different notation for this because I'm not saying like I normally do. Like, listen, if I wrote S sub 57, bless you, under normal circumstances, that means, hey, go find the first 57 terms sum in this series. We're not doing that. We need a different language for this because we're plucking out part of it, not necessarily the first 57 terms. So that's why we have to kind of learn this from a different perspective. So, again, we're going to take n, which is 57, times the two terms added together, which are 13 and 225. And then we're going to divide whatever that answer is by 2. And this one you should, if you put it in your calculator correctly, you should get 3,933 if things have gone well. So do you have any questions on the arithmetic? It's not a very complex thing. It's new language, but the math is not that intense. Okay. So let's do some geometrics. A couple. So the notation will, again, you'll recognize it right away. So it's going to say the summation of the terms running from n equals 1 to n equals 5. And the expression is going to be 5,000 times 1.05 to the power of n minus 1. So you get that all the stuff that's after the summation is the math. That's like the function being defined. And so the thinking is the same on this one. Before we begin, let's write down a formula for this one. So I have this, and I'll try to clean this up for you. I thought about scanning this and just sending it to you, but for geometric, you're going to want to do this one. You're going to want to say a sub start. Here's what it looks like officially. So I want to say this so that if you look in some college math book, you'll see it this way. It's going to say a sub 1 times 1 minus r to the nth all over 1 minus r. Does that look familiar?
Yeah.
Yeah, you already know this formula, by the way. We don't even change it up for geometric. I did change one thing. I factored out the a sub 1, which I did the other day. I don't know who was here, but this version of it is just different. So if you wanted to leave the other version where you go a sub 1 minus a sub 1 r to the nth, it's like a same. This one, I like this one a little better. I should have probably done it this way the first time. Got it? So we're just going to use the old standby formula. But again, I would encourage you to think about renaming a sub 1 as a sub start, which coincidentally in this case is the same thing because we're summing the terms from 1 through 5. But that's going to change. And so again, a sub 1 is more like a sub start. So if you're into that kind of thing, like I don't know how you felt about that when I did it last time, but if you wanted to, you could change a sub 1 to like a sub start. Completely up to you. Okay, so let's get right in. Let's dive right in. And this one you already actually know how to do because we're starting at the first term. Where the newness is when we don't start at the first term. If we sum like terms 2 through 10 or 20 through 23, that's where the newness is. But this is old hat. So our first term is going to be a sub start, which specifically is a sub 1. And I don't need a calculator for this one. Why?
Because it's 0.
Because 1 minus 1 is 0, and 1.05 to the power of 0 is 1, and 5,000 times 1 is, of course, just 5,000. I'm going to need a calculator for this one, though, right? What's coming next? You agree? So notice in this one, we don't have an a sub end. Okay, this formula is not interested in that. This formula is interested in tell me what the first term is, and you march me forward from there. Okay. Let's do it. So if we plug stuff, let's make a cast of characters. I apologize. What's R? Nice job. Good catch on that. And then what is N going to be?
6.
5. And just don't ever abandon the formula. You take the high N value minus the low N value and then add 1. Just like every time, it'll work every time. Okay. So that means we're summing 5 terms. And now I have my cast of characters and I can just plug them in. So what's going to go firing into our calculators in this case is going to be the first term, so 5,000 times 1 minus 1.05 to the power of 5. Please note that that 5 is inside, not outside. You'll obviously get vastly different results if you do 1 minus r and then exponentiate that whole thing. So please make a note of that, that the n is in there only on the r. And then we're going to divide by 1 minus r. And I feel like that's math I can probably do, you can probably do with me. What's 1 minus 1.05?
Negative point.
Negative 0.05. So this red box indicates what we will type into our calculation. We've long since left now the realm of thinking we would want to do this in our heads, right? Go ahead and take a moment, try typing it in. I'm going to pour myself a late afternoon cup of coffee here, and then we'll do one more problem. And then I had a ton more examples, but that's, if we get through this and one more, that's a victory for the day. Totally. Short day like this, so.
Did you have to host White Top?
Mhm.
Why don't you have morning practice?
So if we're talking about morning practice, we must have already typed this into our calculators. And if we typed it in correctly, assuming everything has gone well, if you round to the nearest whole number, you should have something that comes out to about 27,628. Okay, and the directions will change. Pay attention. If I have you working in delta, which I might, the directions are going to say always round to the nearest whole number. Mine are going to say usually round to a couple decimal places. So just always read the directions, okay? And they'll change. So I have one more example for you. And the reason I want to do one more is because this is an example of what we call exponential growth. All right, R is what we call a growth factor in exponential problems. And what it means is that something is increasing by 5% at every iteration, right? That would be like I buy something and every year it gets 5% as valuable as it was the year before. That's growth. I want to do an example of decay. Okay, so we're same thing. We're going to set it up. We're going to have our sigma notation. And we're going to start down here at n equals 2. And we're going to go up to 28. And our expression is going to be 400 times 0.91 to the power of n. So again, we need to, I feel like I say this a lot, but like before I start, I want to know who my characters are. I want to be able to open up that book and say, I got you. I got all my players for this game. And so the three things that I need, the three variable values that I need are a sub start, which in this case is which term? A sub 2, right? We know that we're taking out the chunk that starts with term number 2 and going all the way up to term number 28. So we want a sub 2, we want r, and we want n. So let's see if we can figure all those out. And we're going to definitely already want a calculator because a sub 2 is well outside a normal person's comfort zone. Like I'm a math nerd and I love trying to calculate things in my head, but there's no way I'm doing 0.91 squared times 400, right? And just pay attention. Sometimes it's going to say n plus 1, n minus 1, just regular n, like it's going to change from one problem to the next. I'm going to type this in real quick. So if I do 400 times 0.91 to the power of 2, I hope we all agree, we get 331.24. So again, it doesn't mean that 331.24 is the first term of this particular sequence. It just means it's the first one we give a crap about, right? And then what's R? 0.91. So this is now, it's when you have a growth factor that's under 1, then we're dealing with what we call decay, exponential decay. It means it's losing 9% of itself every period, every go round, right? And then N is what? It's the moment of truth. 27. Did everybody get 27? Top minus bottom plus 1, 27. You guys are good. And then let's plug it in. And so what it's going to look like, what we're going to type into our calculators is going to be a sub start. So in this case, 331.24. And then we're going to multiply that by 1 minus r 0.91. But the 0.91 is going to get exponentiated up to the 27th power. And then we're going to divide that all by 1 minus r. And what's 1 minus 0.91? Wait, 0.09. And I mean, that's it. I mean, like if you are successful, I don't say that like in jest. As we know, calculators sometimes knowing how to use it can be the difference between getting it right and getting it wrong. So if you're successful and you hit all the right buttons, it should come out to around 3,392. Is that looking like what we got? Scott, are you okay?
Well. What?
Um, I'm out of time because we only have a minute. So I think we made a lot of ground for a day like this that's a shortened schedule. So tomorrow, I don't really know that I'll have any lecture stuff to continue. Um, we'll do a lot of work tomorrow. So Sutter, did you figure it out? Can I look at it if you didn't?
Well. Yeah, well.